takes about 2 months. And again, you need $1 billion facility to make traditional propellant. Our process has cut that down to roughly 6 hours. So we've really changed the game in terms of the ability to have a continuous production of propellant all the time. We're not dependent on molds, so we don't have to have several different variations of molds. Our propellant cures in a single spot. And we've cut the time to produce all of this from weeks and weeks to just hours.
Everyone talks about missiles, but almost no one talks about the bottleneck that decides whether they actually get built. Today's guest is Will Edwards, CEO and co-founder of Firehawk Aerospace. Will's a Forbes 30 Under 30 honoree, and this isn't his first company. But Firehawk is the one he started after realizing something was seriously broken. Demand for missiles and tactical systems is exploding, but propulsion manufacturing is still slow, expensive, and way more fragile than most people want to admit. Firehawk is flipping that model with 3D printed rocket propellant built for speed, scale, and cost. And they're not just talking about it. They're building the first U.S. facility dedicated to 3D printed rocket propellant to actually make this real. Welcome, Will.
Thank you very much for having me. That's a great intro. I appreciate that.
Well deserved. We'd met through a previous guest, Janet Grondin at Stellant, and she said, you got to have Will on. And I've been looking into you and was really impressed with the new facility you're building out.
Yeah, Janet is one of my favorite people. She's CEO at Stellar, and Celeste, the founder of Stellar, she has invested in every single round of Firehawk Aerospace. So I'm a big fan of the Stellar team. They've been extremely helpful to us.
Shout out to Stellar. We will link it in the show notes. Don't miss that episode we did with her as well. That's awesome.
Absolutely.
So everyone obsesses over missiles and platforms we hear a lot about. Why does propulsion end up as the quiet bottleneck?
Because it's hard. It's hard. It's very expensive. And there are really just two companies in the United States doing it, Aerojet Rocketdyne and Northrop Grumman, Orbital ATK. So these companies have invested billions of dollars into their facilities. And some of the most brilliant people in the world work for these companies. They're just doing an extremely hard task. And it just ends up being a bottleneck. There are a lot of bottlenecks in this industry. Propellant and rocket motors just happen to be one of the very dangerous bottlenecks that take a lot of time.
So I'm curious, when demand spikes, as it has done recently, what breaks first in the propulsion bottleneck, as we're talking about?
Oh gosh,
a lot of things.
Yeah, it depends on what system you're working on. People say nozzles, cases. It really does depend. Propellant's always an issue, so that's hard. The truthful answer is what breaks first. Usually multiple things all at once. It just depends on how big of a missile are you building, how big of a rocket are you building, and what happens to be the certain bottleneck in that particular system.
Mm-hmm. Could be anything, it sounds like.
Could be anything. It could be about a few things that are difficult, but lots of providers of, I think what's different about propellant is for all of these different, systems like fuses and cases, there are a lot of providers out there, but propellant, the United States is really dependent on Northrop Grumman and L3 Harris.
That is an incredibly dependent supply chain on two suppliers. It's high risk.
Very.
So Firehawk isn't your first company. Will, what did building your first startup teach you that made you see this problem in the first place, and then also made you see it differently?
I think that so my first company was I patented electronic flashcards and quizzes for learning people's names. So I just made an API that would go. Yeah, it was fun. It was a college project that I made for my fraternity and the different sororities, and it pivoted to an HR software. I think that, listen, HR software, it's a slow process to sell into as well. So it taught me a lot of patience. You don't just go in and plug your API into some of these companies and expect immediate results. I learned the first elements of fundraising. That company never really had to raise all that much money, but I was surrounded by a lot of folks who did raise tens of millions of dollars or hundreds of millions, some of them. But I think most importantly is I didn't come from the industry. When you look at what Firehawk does, and I know we'll get into it, but we use a totally different material for the base of our propellant and our processes. So I didn't have all these years at a SpaceX or a Northrop Grumman
Or even that thought of this is the way it's done.
exactly. I had no idea. I was learning as I was going, and I had a co-founder who was doing a lot of the tinkering himself. But for a while, I was just this crazy guy walking around conferences with a tube of Lego plastic that was our base for our propellant.
A tube of Lego plastic.
Yeah, we print. I don't have any on me right now, but we we print Lego plastic in these cylinders, and that's our base. It's ABS thermoplastic instead of using traditional thermoset polymers. So everyone was like telling me all the reasons why this would never work. All the reasons they were telling me, I really didn't know or care. I just knew that we had a path. I mean, everything comes down to like the voids, the porosity. You won't be able to print the structure like sound enough, and so like it'll collapse on itself. Air bubbles will fill up, pressure will occur at different parts, and
So he had some really smart engineers telling you, it's never going to work.
and as finance major, graduated from Arkansas. My sister's an engineer for Boeing Defense, and she was telling me, "Hey, Will, I don't do this." But no, I mean, we were dead set. We thought that we could start 3D printing rocket propellant, and honestly, it turned out that the thing that everyone told us not to utilize was the key differentiator that ultimately led us to being able to reliably print 3D printed propellant with ammonium perchlorate, highly loaded grains. So, I mean, a little bit of luck, but also
What
just
made you
determination.
believe that it would work?
I had to. I mean, like I
Failure
had
was
to.
not an option.
Yeah, I did not see failure as an option, and
The
also
flashcards had been sold.
exactly. We'd done enough flashcards and quizzes. I was like, it's time for the next thing, and that's rockets. But no, I think that there are a lot of people who are just so adamant to say no quickly, and when I think back on it, if I saw past Will walk up with a tube of Lego plastic or any other thing and say, "Hey, I'm going to sell this to the government and build a rocket company
It
out of
does
this,"
sound
I
nutty. We
it
can all
does sound
agree.
nutty. It does, but that's very much part of my personality. I love proving people wrong. I really don't care what people say about me, because the great thing is I don't come from this industry. So if I became a laughing stock in the rocket industry, I don't know. I didn't know anyone at the time. I do now, but I what do I have to lose? I'll never see them again. I'll go do anything else. I wanted to prove all these people wrong who I didn't care about or know, and really held on to that grudge for a few years.
That seems to make great recruiters. That's your fallback career too. um, there you go. I love it. Okay, so the defense industrial base. Three words that get tossed around a whole lot. And we've got all of these thoughts about slow moving processes as well. What made you think this is going to hold?
What do you mean this is going to hold? Like this is an
Was there a
opportunity?
moment where you were like, I can take on the defense industrial base? This is going to work. Like, when did you know it was going to work?
You know, uh, I think from day one, to be perfectly honest, I knew I can make something out of anything. I'm confident in that. It might take me a while, but I'm not going to just throw up my arms and say, all right, I'm done. I'm going to quit and go somewhere else. No matter what Firehawk was doing, I knew that I would find the people to make something work. So when Firehawk got started, we were building hybrid rocket engines, and a hybrid engine is half solid, half liquid. So we would use nitrous oxide to merge with our solid fuel, and that was the initial product. Now, what we learned over time was you can't really put a hybrid rocket engine into missile and defense systems reliably. The one rule is don't disrupt the military supply chain. Improve it, but don't disrupt it. And if you wanted to sell and put hybrid rocket engines into missile systems, you're going to screw up a whole lot of things. So what we did was we took our base thermoplastic, the Lego plastic tube, and we worked on that for several years. And we are like, we need to figure out how to print this so it's a solid propellant. And the difference is that solid propellant is mixed into the Lego plastic tube. We don't have an extra canister of laughing gas or nitrous oxide. And we need to be able to reliably print this and essentially be a one-for-one swap for traditional solid propellant. And the reason why that's a big problem to solve is it takes about 2 months. And again, you need a $1 billion facility to make traditional propellant. Our process has cut that down to roughly 6 hours. So we've really changed the game in terms of the ability to have a continuous production of propellant all the time, the ability to not, we're not dependent on molds. So we don't have to have several different variations of molds. Our propellant cures in a single spot. And we've cut the time to produce all of this from weeks and weeks to just hours.
2 months to 6 hours? Is that what you said?
2 months to 6 hours. And that's not even talking about the base bleeds that we do for artillery shells. A base bleed is
let's talk base blades. Let's hear it.
I love base bleeds. They're awesome. But
I can see your face. So yeah, we're going there.
I mean, we're going to be releasing some pretty cool videos of what our factory in Oklahoma is going to look like.
Is it going to cost you $1 billion?
No, it's nowhere near $1 billion. It's a lot, but it's not 9 figures. We're talking 8 figures. So, but a base bleed essentially extends the range of an artillery shell. So it's a little motor that looks like a donut cut in half, essentially, that spews a gas and extends the range. Those are very tough to make because you have to go through, traditional mixing, curing, casting of the propellant in these tiny little molds. And that's about a 6-week process. We've cut that down to a batch every 5 minutes with our process. So that's a game changer. We're going to be making hundreds of thousands of base bleeds or have that capacity to make that starting next year.
Every 5 minutes. And it had taken 6 weeks.
Yes. Yeah. And you need to make a change to that base bleed. The same machine that is stamping out those base bleeds can make the other variations of the base bleeds. You don't have to go in and do a whole factory swap.
So Firehawk is disrupting the defense industrial base in this realm.
I like to think we're coming in because I'm also a big believer. The most brilliant people in the world work at these primes. We're going to come in and assist the primes and help them make just a little bit more of their product.
There you go. Channel partnership, all about framing. I like it.
That's all defense is. Anyone who says that defense isn't, just start looking at some of those primes or those neo primes and see who they're starting to partner with. It's all about channel partnering.
We're going to go there. But before we go there, back to this manufacturing and, total change in terms of speed on the process. Why do you think we hadn't gotten there until now? What do you think the biggest lie we tell about manufacturing and legacy manufacturing is?
Yeah, I would say, the reason why, again, these companies, they have to invest hundreds of millions, again, if not billions of dollars into these facilities. And then those facilities are typically backed by some sort of multi-decade long contract. So if they built these facilities in the 70s, 80s, improved on them in the 90s,
you're getting paid via the contract.
Yeah, and you can't just pivot. Otherwise, you're going to have to go spend, especially with how these larger companies move, you're going to have to go spend hundreds and hundreds of millions of more dollars just to restart when they're already making money.
Well, we're both finance majors. So you think the financial setup of traditional manufacturing just didn't reward the innovation?
Exactly. It did not reward the innovation, which is why defense startups have such an opportunity because we don't have any debt of any debt from our facilities. Yeah, we can just get started. You can go get a warehouse, go and start building things that other companies wouldn't focus on or pivot.
Not chained to the debt somebody else acquired 10 years ago kind of thing.
Exactly. No facility debt, which is critical, or infrastructure debt.
You work with some pretty big names, Army Application Labs, AFRL. I know I'm forgetting one.
Yeah, I mean, Army Applications Lab, Army Futures Command, AFRL, different groups within the Air Force, and then partnerships with other companies as well. We've worked with Raytheon, Hanwha, CSG out of the Czech Republic. So we're building our reach both domestic and international.
Okay, so tell me, almost from a branding perspective, why is it so important in terms of scaling to be a partner as opposed to a disruptor?
Because defense is a components based business. I've said this 1,000 times, and but like
But people are kind of snobby about that though.
they are,
Like I'm a systems guy, I don't do components, but I have seen many fortunes get made in components.
and everyone wants to, like what sells in the startup world is a big flashy full system, but they don't talk about how all that money that these companies are raising are going to vendors that are, you know, that's the small that's a small partner for those vendors because they're making hundreds of millions, if not billions of dollars from the primes. So if you can build something that the primes already have program funding for, already have facilities that will produce something that utilizes what you're building, there's a fortune to be made. That's why base bleeds are such an opportunity. Very few people want to make them. Very few people want to make these basic rocket motors.
Because they're seen as unsexy.
They're definitely unsexy in the startup world, and then they're just not the.
They're not UAVs.
Yeah, exactly. They're not UAVs. They're not the big winners for the primes, but I mean, they're companies that are making billions of dollars a year making unsexy things, and Firehawk just wants to improve how we make those unsexy things and then sell them to the people who will put them into something sexy, maybe.
I love it. Okay, so we need the primes essentially to support and scale innovation. Uh, how do you collaborate with them? Without slowing to a crawl, because it seems like we'd have this dichotomy between fast break this startup culture and bureaucracy and slow move with primes.
Yeah, I mean, listen, there are definitely some primes where I want to bang my head against the wall. I actually typically don't go to those meetings when they come, but there are others. I'll be frank, Hanwha Defense USA. That group is moving, and they are eager to work with folks. They have a lot of money. They have very sophisticated engineers. They are looking at things the right way, and I think Hanwha Defense is going to be a major player
Serious
in the.
player.
Oh God, yeah, they're pretty incredible. They're moving fast, and then yeah, there are a lot of other primes that they have a lot of risk that they're always accounting for. And if you're incumbent, even government customers see new companies as a risk. You're like, how big of a risk are you to this program? And both primes and the customers see that, so they're always going to be hesitant with you.
When do you stop becoming a risk?
It's interesting.
It's like a revenue or employee size, or like, do you need to be 50 years old?
It's like I mean, yeah, that does help. I think one way you can be less seen as a risk is raise a lot of money. And by a lot of money, I don't mean hundreds of millions, like billions.
Or if you get hit by a bus, somebody else is going to take over because it's funded.
Yeah, or yeah, exactly. Or if that program goes it like costs way more than the company thought it would, they will fund it, because what we're all looking for too is past performance. So it's really a chicken before the egg situation. You have to have a facility for people to take you seriously. If you have a facility, you also have to have past performance to be taken seriously too. And it's like, okay, well, I can't afford to get this facility unless I have these big contracts, or a reason to get a big facility unless I have a big contract to fill that up with. But I also can't have past performance if I don't have this facility. So startups have to raise a lot of money and then go after contracts that aren't like the biggest money makers, like the primes are all focused on. But you start getting that past performance, you got to deliver. My VP of Fed, she always says what's worse than not winning a contract is winning a contract and not delivering on it. And so we take that very seriously. But listen, you gotta invest and roll the dice a little bit. But there's a way to go after opportunities where you can make money. You can start building up that past performance, that track record, And then if you are doing something slightly innovative like Firehawk is, and you can build that facility that can produce 200,000 base bleeds a year, you can put yourself in a really strong position in just a matter of a few years to go after 9 figures, if not 10 figures of revenue.
That's how you scale.
Yeah,
And look for the unsexy gold mines.
they're everywhere.
5 to 10 years from now, what will propulsion supply chains look like if we get it right?
I think it'll be a lot more robust. I think it'll look very much the same. We will have Orbital ATK, Northrop Grumman, and then uh, Aerojet Rocketdyne with, I guess Aerojet's going public now, but Aerojet Rocketdyne, they will still be there. They will be power players. We'll have some new incumbents like Nammo. They're growing. They have very, very smart people working there as well. And then I think you'll see a lot of these other companies like Firehawk that are filling a big role. Because one thing that is for certain is no single company can supply all the demand that's needed. And we're talking tens of billions of dollars worth of demand over the next several years. So I think two things: you'll see a lot more of us. And I think Firehawk will be one of the leaders because we will be the only one that invested all of its time and money to perfect 3D printed propellant. And we will essentially corner that market for the systems we're going after.
You're building the first US facility dedicated to 3D printed rocket propellant. Why does putting it on US soil matter right now?
Well, it's critical. You got to have it on U.S. soil to get those government contracts. I'm proud to have it in Oklahoma. I'm from Oklahoma, so it's cool to get to see this all come full circle. And we get to have it in Lawton, Oklahoma, which is right next to Fort Sill, the Army's fire centers of excellence.
Well, there's a ton of aerospace in Oklahoma. I know Rick Nagle was on our podcast earlier, and the stats he threw out was wild. I think it's overlooked state in terms of aero as well.
I'm pretty certain the person who builds the steps for Air Force One and Air Force Two is a guy in southern Oklahoma.
Little Oklahoma pride.
Yeah, I mean, there's a lot of amazing things in Oklahoma. I mean, just not to mention they're a powerhouse in Congress. So they're constantly growing. Like they have Tinker, they have Fort Sill, they have great support with their U.S. senators and their representatives. So it's a great place to build. And yeah, for us, I think it's pretty cool to have the first 3D printed rocket propellant facility in the United States, in the world, but have it in Oklahoma. And it's going to be an incredible facility. And not only that, it's great for Firehawk. We have 340 acres that we're building in Oklahoma. We just bought a 636 acre rocket and missile facility that we're turning back on in Mississippi. So we have everything extremely close to each other between Mississippi, Texas, and Oklahoma. It's going to be a great little region, I think, for aerospace, and it'll keep growing.
Well, this is a story about building teams, and I get asked this question at least once a week of, hey, we're looking at where to put this team. Where would you recommend right now? And the traditional, hubs, everybody's in SoCal, but nobody can afford to live there. So nobody says SoCal anymore. Phoenix was hot, but it can be really challenging when you're looking at granular engineering positions too. Dallas seems to be the number one next to Huntsville these days. I'm seeing Florida as always. You're looking at Mississippi and Oklahoma, which are outside of the traditional range. We see Dayton a lot too. But what prompted you, besides being your home state, to think this is where I want to set up shop?
Well, we're headquartered in Dallas. We still have about 100 people here in Dallas, Texas. So it just made perfect sense that Lawton is about 2.5 hours away from us. It's by the Army. It has the workforce. They have people retiring from Fort Sill every single year who are shooting the systems we want to build, who have worked on those systems as well. It's either, I always mess it up, but like they have the largest Goodyear plant. It's either Goodyear or Michelin.
So you got some people to draw from.
They have a lot of people there. And then Mississippi, we're opening up a place in Huntsville as well. Mississippi's phenomenal too, because they have a bunch of aerospace companies there, and all the workforce that we would need to run a facility like that is in Mississippi. Plus, these are all pleasant places to live in. Like you said, I used to live in Santa Monica. That was beautiful, but a nightmare. It was expensive as can be. In Texas and Oklahoma, Mississippi, Alabama, you can buy a home. You can send your kids to, a great public school.
Oh, I know. And everybody I have relocated to Huntsville are like, Katherine, you promised me the commute would be something I like. It's 20 minutes today.
Yeah, yeah, exactly.
They complain about 20-minute commutes.
Yep, yep, and that's beautiful. I'm jealous of that, and they have the trash pandas there too. I love the trash pandas in Huntsville.
Well, for those that don't know about the trash pandas, well, tell us
They
all.
are their minor league baseball team. Best logo ever.
If you haven't seen them, go check them out.
Yeah.
Well, before I let you go, zooming out, if Firehawk succeeds, what fundamentally changes about how fast the U.S. can respond in real conflict?
One of the biggest issues one of the most complicated things with artillery shells is producing base bleeds. We're going to give them the opportunity to have just a surplus of whatever they need when it comes to that specific system, that those base bleeds. But I think the bigger impact is for the United States and for our allies. I mean, we will be able to allow rocket propellant production, base bleed production, all these really hard, typically unbelievably expensive and time consuming processes. We'll allow all these countries or the United States to build rocket factories anywhere in the world. So we're not shipping them just from the States. We can produce a country or two countries away from the conflict and just save a fortune on logistics. So
that's a pretty incredible vision.
We're going to be the gas station for rockets.
The gas station for rockets. I love it.
Yeah. Oklahoma is a pretty big state for gas stations. We have Quick Trip, Love's. They're all founded there. So,
continuing the legacy forward.
That's right. But for missiles and defense systems.
Well, we will be watching you. Thank you, Will. Congratulations on your early success.
Thanks, Katherine.